this math, y'all, we have to go into converting radians to degrees and degrees to radians. So here we are. We're going to jump into converting radians to degrees and degrees to radians. So in our last video, we learned that 180 degrees is equal to pi radians because the whole circle is 2 pi, which is 360. We didn't talk about that. And so 180 is equal to pi. And this is our conversion factor that we're going to be using. So to convert degrees to radians, and we're going to leave our answers in terms of pi. So what we're going to do is we're going to multiply this by our conversion factor with the degree number on bottom. Remember, 180 is equal to pi. So we can either do 180 over pi or pi over 180 as a conversion factor. These problems, we're going to do the second one. So now when I multiply this, I'm going to get 18 pi over 180. Now this needs to be reduced, put in lowest terms. We need to simplify the fraction part. Just separate out the 18 over the 180, and then we'll stick the pi on it. Both of those are reducible by 18, so I get 1 over 10. And so this is going to be 1 over 10 pi, also known as pi over 10 radians. So 18 degrees would be pi over 10 radians. Next, we're going to do the same thing. We're going to multiply by pi over 180. And so we'll have 75 over 180 pi. Again, I'm going to reduce this fraction. I'm going to reduce this one by 5. And that's going to give me 15. Is that right? I think so. And 180 divided by 5 is going to give me 36. All right, and then I can reduce by 3. So that would give me 5/12 pi. 5/12 pi. So that's going to be my radians for this one. It would be 5/12 pi. All right, now let's go the other way. Let's go the other way. This time we're going to have a radian measurement and we need to convert to degrees. So this time we're going to flip our conversion factor and multiply by 180 over pi. It goes into canceling. You kind of know which one wants to cancel. You kind of know which one to put on the bottom. And so this time the pi's are going to cancel, and we'll have 180 over 9, and that is going to simplify to 20. So that would be 20 degrees. This one, the pi's cancel, and I have to do 13 times 180 over 12. I might need to do a little fancy calculator work on this one. I can reduce 180 over 12. This one I can simplify by 6. I can do both of them by 6. That might be the quickest, or at least the first one. Let me put a little color in here to help you out here. Reduce these by 6, and that would give me a 30, and that would give me a 2. And then I can reduce the 30 and the 2, just reducing my fraction. That'd be a 1, and that would be a 15. So now I have 13 times 15 over 1. Definitely need to pull out my calculator now. I don't know 13 times 15 right off the top of my head. So let's see what we have here. 13 times 15. Sorry, it's taking me so long. 13 times 15 is 195. 195 degrees. Okay. So now let's think about what we know about these two to make sure they make sense. Pi over 9 is smaller than pi over 6. We'll go back to our circle, and we saw, where's our circle? There we go. Pi over 6 was 30 degrees. Pi over 9 is 20 degrees, which would make sense. If I was to do pi over 9, it would be right in there somewhere at 20 degrees. And that makes sense. Let's see if our next other one makes sense. 13 pi over 12. 13 pi over 12 is just a little bit bigger than 12 pi over 12, isn't it? And 12 pi over 12 is just is a little bit bigger than 180. So this one should be just a little bit bigger than 180. And the answer was 190. What was our answer? 195. Again, that's just a little bit bigger than 180, so that one makes sense as well. All right, now we can convert using decimals. Back here we did whole numbers. Back here we did in terms of pi. We can do radians in decimals. Let's look at this circle. We can use decimal radians. We don't do these very often. They get very hard to deal with. We do not use them. They're not efficient at all. Fractions are much more efficient. Trust me. But you need to have a good understanding of numerical content here. We need to know. Pi radians would be 3.14. That's the decimal approximation for pi. Pi over 2 would be literally 3.14 divided by 2. We do that in the calculator. We get 1.57. And those forth. This would be pi divided by 6. And this is pi divided by 4. You can test those on your calculator. These are the actual decimals, the actual radian measurements in their decimal format. The decimal is also approximated. Again, the reason why we use the fraction, because they are exact. No approximating necessary. But what about 2? 2 doesn't seem like it's a fraction, but 2.0 radians, or just 2, should be over here in the second quadrant somewhere. 2 radians. We're going to convert 2 radians to degrees. So again, we're going to do the same thing we did before. Don't need this 0.0. But I'm going to multiply it by 180 over pi. Now the pi's don't officially cancel. I'm going to actually have to do the decimal on my calculator. I'm going to actually have to do this on my calculator. So I'm literally going to do 2 times 180, which is 360, and I'm going to divide that by pi on my calculator, and I'm going to get oh goodness, 360 divided by pi. I'm going to get 114.59. 114.59 degrees. So that's the degrees for 2 radians. And 114 degrees, if you recall, is somewhere around here, because this is 120 degrees. And so it's around here somewhere. That would be 2 radians. Okay? So just to kind of give you an idea of how we do that. All right? And 215 degrees to radians. So again, this one's 215 degrees. This time we're going to put the 180 on the bottom so that the degrees can cancel. The pi's on top, and we want a decimal. So literally I'm going to do 215 times pi divided by 180 in my calculator. I'm not going to do a fraction this time. I'm going to do a decimal approximation. I'm going to use my calculator. 215 times pi, and I am using the pi button, not 3.14, divided by 180, and I'm going to get 0.70. Let me do that again. 215 times pi divided by 180. That's much better. 3.775, and that's approximately radians. Now it should make sense as to where it is in location. 215 degrees, we know that this is 210. We know this is 225 degrees. Okay, and so 215 falls in here somewhere, which would be 3 point something radians. 225, we can do the decimals for all of those for 210 degrees if we want to, but that's where it is, and it's going to fall a little bit bigger than 3 radians, 3.75 radians. All right, So just in summary, when converting, you're going to do multiply by pi over 180 or multiply by 180 over pi, and it all depends on what you want to cancel. If you have degrees, you want degrees to cancel. If you have radians, you want the radians to cancel. If the answer needs to be in degrees, use a calculator. I mean decimals, I'm sorry. If your answer needs to be in decimals, use a calculator. Otherwise, avoid that calculator and leave them in fractions in lowest terms. All right, it's just math, y'all. Hope that helps.